So now we're going to talk about the different stages of sleep and the different types of brain waves that are associated with each one of those. So here at the top of this slide, there is a video that I typically show when I do this in a face-to-face class. But just to keep this video a little bit shorter, I'll let you go ahead and you can go back to the lecture notes that are posted on Canvas and watch that on your own if you'd like. So before we go into the stages of sleep, we need to talk about how we actually measure these stages. And so think back to when we talked about those different ways we examine the brains and decided how different functions were associated with different brain regions. Can we remember what type of measurement we talked about that would be used for measuring the stages of sleep? It was an EEG. Yes, and so here are the different types of brain waves that are associated with each one, and we're going to go into some details of each of these, what types of brain waves are associated with stage 2, the differences between stage 3 and REM sleep, and all those shortly. But another measurement is also a polysomnograph. And so here you see this guy all hooked up to the different machines. He's probably in a sleep lab, and they're measuring not just his brain waves, but his pulse, his eyelid movement, all of those different types of things. All right, so first we get into stage 1. And stage 1 is when sleep has just begun. So it's dominated by irregular, jagged, low voltage waves. They're called theta waves. And so here you see this is what it looks like when we're awake. And here now it's kind of slowed down a little bit. You can see how they're irregular. They're not the same. They're very jagged and they're very low voltage. So this is considered light sleep. Brain activity begins to decline. You're becoming more relaxed. Your muscle activity slows. There might be an occasional twitching. And if you're a good sleeper, this is going to only last about 5 to 10 minutes. We then transition into stage 2 sleep. And stage 2 is characterized by what are called sleep spindles. And so these sleep spindles are little bursts of activity, 12 to 14 hertz waves that last about a half of a second, and K complexes, which are these very sharp, kind of high amplitude waves with a smaller low positive wave. So here's what a K complex looks like, and here's what a sleep spindle looks like. So here's a sleep spindle, this burst of activity that lasts about a half a second, and here you have this K complex. And so again, it's important to understand that those characterize the stage 2 activity. Overall, your brain activity is continuing to decrease. Heart rate and temperature also decrease. And this is the light sleep. This is what we spend majority of our night in, is stage 2. The next stage is stage 3 and stage 4, and we lump those together even though they are distinct stages because they are both characterized by what's known as slow wave sleep. So slow wave sleep means that the waves are slow. They have these large amplitude. They're also known as delta waves. So while we had theta waves in stage 1, we now have delta waves in stage 3 and 4. Everything continues to slow down. Your heart rate slows down, your breathing rate slows down, your brain activity slows down, and as a result of that, our neuronal activity becomes highly synchronized. So down here is just showing you what those delta waves or those slow waves look like. You see, again, they're slow, they're kind of farther apart. They have this high amplitude, so amplitude is going up and down, and that's these slow wave, these delta waves. So stage 3 and stage 4 are different though, and what differentiates them is that in stage 3, we have less than 50% of slow wave sleep, so less than 50% of these delta waves. And in stage 4, we have greater than 50% of these delta waves. Now, stage 3 and stage 4 is thought to be very important in restoration. It's thought that perhaps that's a time period where the brain kind of cleans out some of the gunk for the night. And after sleep deprivation, there's a rebound in this type of sleep. So if you pull an all-nighter, or you don't get enough sleep, the next night you come back and your body craves more of this slow wave sleep. So the next stage of sleep, which would be stage 5, is known as paradoxical or REM sleep, probably referred to more often as REM sleep. And do we know what that REM stands for? Rapid eye movement. So that's where the REM comes from. And so one group, why it has two different names, that one group was looking at eye movements in people hours after they were asleep. And they said, they're in this deep sleep, but their eyes just started moving suddenly. And so this rapid eye movement sleep is basically characterized by rapid eye movements. It also has another name because this paradoxical sleep, because another group that was studying it in cats using EEGs said that while these people look like they're in the deepest part of sleep, maybe even deeper than slow wave sleep, their brain waves don't look like they're in a deep sleep. So the EEG waves are irregular, they're low voltage, and they're fast. Do you remember what that sounds more similar to than slow wave sleep or a deep sleep? It looks very similar to what our brain waves look like when we're awake. However, and that's what you can see here. If you look here, you can see this is what our brain waves look like when we're awake. And this is what they look like when we're in REM sleep. And so so here's awake and here's in REM sleep. But the paradoxical thing is that while our brain waves look very similar to being awake, our postural muscles are very relaxed, more than the other stages, so that we seem like we're in this very deep sleep, but our brain waves are very active. So this is the stage of sleep we think about when we think about dreaming, although we can dream in other stages of sleep. This is also when we'll talk in a few slides about how, or possibly the next video, about how during REM sleep, the pons actually issue order to your postural muscles to inhibit the movement of your muscles, so you don't act out those dreams. All right, so this diagram is just kind of showing you everything combined. I'll let you go ahead and kind of look at this part on your own. It's just kind of a summary. Note here that we mentioned that stage 2 was the stage that we spent the most time in throughout the night. Stage 1 you see here is characterized by those theta waves, brain activity declines. Stage 2 we have those sleep spindles and then those K complexes. Here's another big one here. Stage 3 we start to see those delta waves, and notice here how it's less than 50% delta waves here, more than 50% delta waves in stage 4. This is considered our deepest sleep. Very little brain activity, anything that's there is very synchronized. And then we jump into stage 5 where we have rapid eye movement sleep. And so we also spend a significant amount of time sleeping in this stage as well. So down here, you'll see how we cycle through these different stages, okay? So we start when we're awake, we go down to stage 1, into stage 2, down into stage 3, and into stage 4, and we cycle back up, and then we have some REM sleep. And so then we cycle back down, spending some more time in that deep sleep or that slow wave sleep. And we might not go through each stage, through each cycle. Now we have REM sleep, down to stage 3, more REM sleep, stage 3, more REM sleep, stage 2, and then more REM sleep. So a couple things I want to point out. What do you notice here about this latter part of the night? What do you see more? What are we spending most of our time in? REM sleep, right? This is highlighted as yellow. It's REM sleep, and that's when we do a lot of our dreaming. Again, not all of it, but a lot of our dreaming. And what do you see us spending a lot of our time here in the earlier parts of the night? Yeah, our deep sleep or our slow wave sleep. That's stage 3 and stage 4 sleep. So that's an important distinction to remember. And this also might be why, if we're dreaming mostly in this part of the night, we wake up a little prematurely in the morning and we tend to remember our dreams, but not always. And we'll talk about that later on.